Hi guys, hi my friends, my name is IBM and today I'm solving the multiple choice questions of October-November 2023. I hope you have already seen component 1-1 and I'm now solving component 1-2. So without wasting time, I'll take you to the question paper to start solving it. So this is the question paper. It is component 1-2, 2023 October-November. The paper is 1 hour and 15 minutes. So without wasting time, you can read through the instructions. The paper is 40 marks. You can go through the constants which are given. You can also check through the formula which are given. Question number 1. A student estimates the maximum speed of some different moving objects. Which maximum speed is not a reasonable estimate? Okay. The container ship. The speed is 10 meters per second. The speed of a container ship, I think that makes sense. Olympic sprinter, 0.1 kilometers per second. This is the same as we multiply by 1,000 is 100 meters per second. I think the average speed of a sprinter is around 10 meters per second. So it means this does not make any sense. There is no sprinter who runs at 100 meters per second. That is not really possible. So I think B is not correct. You can check C, the speed of a racing car, 9,000 centimeters per second. If I change it to meters per second, this will be dividing by 100, that will be 90 meters per second. And if I change 90 meters per second to kilometers per hour, I think this would be 90 times, I'm changing to kilometers per hour. That would be 90 divided by 1,000 to change it to kilometers. Then, so this is going to be 0.09 in kilometers divided by 1 hour, which is 3,000. Divide by 1 second. 1 second is 1 over 3,600. So in other words, I just multiply that by 3,600, which gives me 324 kilometers per hour. I don't think there is any car with such a racing speed, with such a speed. I don't think the speed goes above 200. It's around 200 kilometers per hour. So it means this is not. But anyway, this is for racing cars. Okay, normal cars could be around 200. Racing cars could go as high as that. So that makes sense. The speed of a snail is 0.01 kilometers per hour. 0.01 kilometers per hour. I multiply by 1,000 to make it reasonable. So I'll say 0.01 times 1,000. 10 divided by 1 kilometer, which is 3,600. Yeah, that is a reasonable speed, 0.003 meters per second. That is reasonable. So is it 0.003? Yes. So it means this is reasonable, this is reasonable, but this one is not reasonable. No sprinter runs at 100 meters per second. Which quantity is an SI based quantity? So this one is not, because it is derived from mass and acceleration. This is a unit, so that is not a quantity. This is a unit, not a quantity. So the answer is D. A student takes measurements to determine the constant acceleration of a model car moving from rest, initial velocity is 0, in a straight line. The measured values with their absolute uncertainties are shown here. So you have displacement and time with their measured values and uncertainties. The student uses the equation S is equal to half at squared to calculate the acceleration of the car. What is the acceleration and its absolute uncertainty? So let's begin by finding the acceleration. So A is going to be twice S divided by t squared. So I'll substitute 2 times S, which S is 16.5 divided by t squared, which is 15 squared. So from my calculator, it is 2 times 16.5 divided by 15 squared. So this gives me 0.1467, 0.1467. meters per second squared. Then I will find the absolute acceleration, which will be, we ignore the 2, so it will be absolute in s over s plus, there is a power on t, so it becomes twice absolute in t over t. Then I will multiply this by the value of the acceleration. So this will be 0.1 divided by 16.5 plus 2 times 1.0 divided by 15. Then multiply this by 0.1467. So I have 0.1 divided by 16.5 plus 2 times, okay, I'll just say 2 divided by, because it is just times 1. 2 divided by 15. Then I multiply by 0.1467. So this rounds off to 0.02. 0.022, just one significant figure. So it means A is wrong, B is wrong, C is wrong. The answer is going to be D. An aeroplane is moving at a constant speed. That means acceleration is 0. In a straight line at an angle theta to the horizontal. 4 forces act on the aeroplane: thrust T, weight W, lift force L, and resistive force R. What two equations must be correct? Remember, the resultant force is 0 because the acceleration, so the resultant force should be 0. Since it is moving at a constant speed, that means the acceleration is 0. At a constant speed, the acceleration is equal to 0, resultant force should be 0. So in the vertical, if I resolve the forces in the vertical, they should balance, and if I resolve forces in the horizontal, they should also balance. So if I consider this as 90, this is 90 minus theta, so this angle is theta. So if I resolve W in this direction, it is going to be W cos of theta. So W cos theta should be balancing with L. Then if I resolve W parallel to the plane, it should be W sine of theta. So it means W sine of theta, when I add this to R, it should balance with the T. So let's see. Automatically, the answer is going to be A. L is equal to W cos theta, and T is equal to R plus W sine theta. So the answer is A. What is the definition of acceleration? Remember, acceleration is the rate of change of velocity. Rate of change of velocity. So this is wrong. This is wrong. This is wrong. It is the rate of change of velocity. So the answer is D. An astronaut on the moon, where there is no air resistance, throws a ball. The ball's initial velocity has a vertical component of 80 meters per second and a horizontal component of 4 meters per second, as shown. The acceleration of free fall on the moon is 1.6 meters per second. What is the speed of the ball 9 seconds after throwing the ball? Let's say after 9 seconds it is here. The velocity in the horizontal remains constant, remains 4 meters per second. It's only the velocity in the vertical which is going to be changing, and this will be got from u in the vertical plus acceleration times t. V is equal to u plus at. So v in the vertical is going to be initial velocity in the vertical, which is 8. Because it's moving against gravity, this will be minus g, which is 9.81. The time is 9 seconds. So this gives us 8 minus 9.81 times 9, which gives us a negative, no, the acceleration is not 9.8. I was using acceleration due to gravity. So the acceleration is 1.62 because we are at the moon. So I'll say 8 minus 1.62 times 9, which is negative 6.58. So what is the resultant? The resultant of these two is the velocity here, which I'm going to call VR. So VR is the square root of velocity in the y squared plus the velocity in the x squared, which will be the square root of 4 squared plus negative 6.58 squared. So I'll just press my calculator. 4 squared plus I'll just say 6.58 squared. Then I find the square root of the answer. So this is 7.7. So this is 7.7 meters per second. So the answer is going to be B. Two blocks of mass 0.2 kilograms and 0.5 kilograms are connected by a light inextensible string that passes over a frictionless pulley. The blocks are initially held stationary. The block of mass 0.2 rests on a rough horizontal surface, so there is friction here. There is friction there. The block of mass 0.5 is suspended in air. Air resistance is negligible. When the blocks are released, they have an acceleration of magnitude 2 meters per second squared. What is the magnitude of the frictional force between the block of mass 0.2 and the rough surface? Okay. So if there is an acceleration, we know that the resultant force F is equal to mass times acceleration. So I'm going to, there's tension here. So tension pulls away from the object every time. Then this one has a weight, which I'm going to call W, and that is going to be 0.5 times G. Okay, so if I consider the block of mass 0.2 kilograms first, so the resultant force is going to be 0.2. Of course, the acceleration is in that direction. So it is 0.2 times the acceleration should be equal to the resultant force is T minus frictional force, T minus the frictional force Fr. If I consider the block of 0.5, the resultant force is going to be 0.5, that is mass, times the acceleration, which is the same A. Then the resultant force is the weight downwards minus the tension upwards. So this is 0.5 G minus T. So I'm going to add the two equations. When I add the two equations, here I have 0.2 plus 0.5, which is 0.7 A. Then T and T plus negative T cancels out. So this is going to be 0.5 G, which is 9.81, plus negative frictional force Fr. But remember, the acceleration is given as 2. So 0.7 times 2 should be equal to 0.5 times 9.81 minus Fr. I'll just press my calculator to find Fr, or I can say Fr is equal to 0.5 times 9.81 minus 0.7 times 2, which is 0.5 times 9.81, then minus 0.7 times 2. So this is giving me a 3.505, 3.505, and this makes our answer to be A. The resultant force causes an object to accelerate. What is equal to the resultant force? Of course, we know that force is the rate of change of momentum. So force is the rate of change of momentum, which makes the answer to be C. The change in momentum per unit time, that is force. That is the resultant force, not just force. Resultant force is the rate of change of momentum. An object falls from a stationary helicopter, which means initial velocity is 0. Initial velocity is 0, and reaches terminal velocity. At terminal velocity, acceleration becomes 0 because v is constant. What happens to the acceleration of the object between leaving the helicopter and reaching terminal velocity? So it means initially, acceleration initially is going to be g, which is 9.81. If air resistance is negligible, is not negligible, initial acceleration is 9.81. Then after, acceleration at terminal velocity is 0. So what has happened? It has just decreased from 9.81 to 0. So the answer is going to be B. So the acceleration decreased from 9.81 to 0. I remember at terminal velocity, when speed becomes terminal, constant speed, the acceleration becomes 0. So it decreases to 0. Two balls of mass m and 2m traveling in a vacuum with initial velocities 2v and v respectively collide with each other head-on as shown. After the collision, the ball of mass m rebounds to the left with the velocity v. Let's first find the velocity of the ball of mass 2m. So by conservation of momentum, total momentum before they collide is going to be the mass of the first ball, which is mass times velocity, m times the velocity, which is 2v, plus the momentum of the other one. Because it's in the opposite direction, it is going to be a negative 2m times the velocity, which is v. That's total momentum before collision. This should be called total momentum after collision. After collision, m rebounds to the left. So that means we are going to put a negative on its momentum. So it will be minus m with its velocity v. We don't know the velocity of 2m, so I'll just say plus 2m, let its velocity be x. So you notice that this one gives us 0, so I'll say 0 equals to 2mx minus mv. Making x the subject, m was cancelled, so x is going to be equal to v over 2. So the velocity of 2m is v over 2 after the collision. So what is the loss of kinetic energy in the collision? So initial kinetic energy before the collision is the sum. The first ball is a half, its mass is m, its velocity is 2v squared. I'm using a half mv squared. Then for the second ball, it's a half, its mass is 2m, its velocity is just v squared. So let's find the total here. LCM is 2, so you have m 4v squared, m 4mv squared plus this is 2m v squared, which becomes, I think this becomes 6mv squared over 2, which gives us 3mv squared. So that is total kinetic energy before. Total kinetic energy after the collision for the mass of m, its kinetic energy is a half m, its velocity is v squared, plus 2m, it's a half, its mass is 2m, and its velocity is v over 2, but this is squared. So this is going to give us a half m v squared plus this 2 cancels with that, v squared over 4, so it gives us mv squared divided by 4. Then when you simplify, LCM is, you can say it is 4. 4 gives us 2 and 1, that is 3mv squared. So the question is, what is the loss? So the loss is going to be the difference. So the loss in energy is going to be 3mv squared minus 3mv squared divided by 4. So LCM is going to be 4. So that is, or I can simply say 12 minus 3 divided by 4, mv squared. Okay, so this gives me 9 mv squared over 4. So 9 mv squared over 4, which is going to be C. Remember, this is over 1, so I just go the LCM or just cross multiply. So a force F is applied at an angle 45 degrees to a door handle at a distance d from the pivot of the handle as shown here. What is the moment of the force about the pivot? Moment of the force about the pivot. So we need the force and the perpendicular distance. So it is as easy as resolving the force vertically. So when I resolve the force vertically, to be F cos of 45. So the distance is going to be d. So the moment is going to be the force times the perpendicular distance, which is F cos of 45, and the perpendicular distance is going to be d. If I resolve F vertically, the perpendicular distance will be d. So this means I'll have FD times cos of 45, I think is 1 over root 2, which means it is FD divided by root of 2. So the answer is going to be A. A couple consists of two forces, each of magnitude F. The magnitude acts in opposite direction in the same plane. The perpendicular distance between the two forces is d. What is the torque of a couple? Remember, the torque of a couple is the product of one of the forces and the perpendicular distance between the two forces. One of the forces and the perpendicular distance between the two forces. The perpendicular distance between the two forces is d. So it is one of the forces and the perpendicular distance. So the answer is C. The diagram shows an experiment to determine the force exerted on a ball by a horizontal airflow. The ball is suspended by a light string and the weight weighs 0.15 newtons. So this one has weight downwards, and if the air flows in that direction, there is tension here. I will call it T. The tension has a component in the horizontal which is balancing with the airflow if it is in equilibrium. The deflection of the string from vertical is that the ball is in equilibrium. So the component of the tension in the horizontal must be balancing with the airflow. What is the force on the ball from the airflow? Okay, so if we first consider the component vertically, it will be, when I use 30 degrees, so this angle is also 30 degrees. So taking T to the vertical, let me wrap it from here, and I write T here. Taking the tension to the vertical, it will be T cos of 30. So T cos of 30 is equal to the weight, which is 0.15 in the vertical. Then in the horizontal, we have the T, of course, elsewhere it will be sine. So T sine of 30 will be equal to the force due to airflow. I'll call it FA. So I'll just divide the two equations. So I'll say F air divided by 0.15 should be the same as T sine of 30 divided by T cos of 30 or tan of 30. So it means the force due to airflow is going to be 0.15 tan of 30. So I have 0.15 tan of 30, which is 0.087, 0.087 newtons. So the answer is going to be B. Two solid cylindrical objects X and Y are held fully submerged in a liquid as shown. The objects have the same volume. Volume is the same. The density of the material of Y is twice the density of the material of X. So if the material X has density rho, this is twice rho. Both objects are stationary. Remember, the volume is the same, V, V. Both objects are stationary. Which statement is correct? So let's check. Of course, if we look, we know pressure on top or the bottom will depend on the depth, H, density times G. Okay. The force due to the liquid on the top of X is greater than the force, is greater than that acting on the top surface of Y. Let's check. The force will depend on this. Remember, force is equal to pressure times area. Okay? They're saying the force on X, note that the area is even small. And this is going to be, the pressure is H, density of the liquid times, this is density of the liquid. So density of the liquid times G times H. Note that H is very small for X, and even the area is very small for X, so it means the force must be less. So it means force on X is on top is less than the force on Y, because the force on top depends on the cross-sectional area. Actually, the force will depend on the cross-sectional area over which the water is exerting its force. So it means this first statement is not correct. The pressure difference between the top liquid due to the liquid between the top and bottom surfaces of X is the same. It can't be the same. Pressure difference due to the liquid. The pressure difference due to the liquid is going to depend on the density of the liquid times G times the difference in the heights. Of course, the height here for X is not the same as the height here, so the pressure difference is not the same. The height for X is not the same as the height for Y, so the change in H for X is greater than the change in H for Y, even though the density of the liquid is the same and G is the same. Rho L is the density of the liquid in which these are placed, so the second statement is wrong. The upthrust acting on X is the same as the upthrust acting on Y. Of course, upthrust is equal to mg, which is equal to the density times V times G, where this is the density of the liquid. Remember, the volume is the same. The density of the liquid is not depending on the objects themselves. and then G is a constant. So that means the upthrust is going to be the same. So this one is not a correct statement. Let me see. The upthrust acting on X is the same as, so the upthrust is the same. The answer is going to be C, because we said the upthrust is depending on the density of the liquid in which they are submerged, not their own densities. They have the same volume, remember, and G is constant, so the upthrust is the same. The weight of X is the same as the weight of Y. This is automatically wrong because weight is equal to M times G, where this time M is the density of X times the volume, then times G. That is for X. For Y, to be the density of Y, which is twice rho, times V times G. So it means the weight of, this is for X, this is for Y. The weight of Y is bigger than the weight of X because of the density. It is actually twice. So this statement is not correct. So the correct answer is going to be C. An electric car travels at a constant speed 70 kilometers per hour for 80 kilometers on a straight horizontal road and uses energy E from its battery. The total resistive force acting on the car is proportional to speed squared. Assume that the electric motor is 100% efficient. How much energy is used from the battery when the car travels at a constant speed of 60 kilometers per hour? Okay, so we know that the energy in this case is going to be equal to the work done. And remember, the work done is the force, which this time is going to be the frictional force times distance. So the energy E for the first one, E is going to be equal to the frictional force, which is equal to a constant. Of course, the frictional force is equal to a constant times the speed squared times V squared, because they say it is directly proportional to speed squared. So frictional force is K times V squared. So for the first one, E is going to be the frictional force, which is a constant, times V squared, which is 70 squared, then times the distance, which was 80 kilometers for the first one. For the second one, the energy, I've called it E2, is going to be the frictional force, which is K, times the speed, which is 60 squared, times the distance, which is 80 kilometers. So we have two equations. I'll just divide them to simplify time, to simplify life. So E2 over E is going to be equal to K times 60 squared times 80 divided by K times 70 squared times 80. So it means E2 is going to be K cancels, 80 cancels. So you have 60 squared over 70 squared then times E. So I will check this. 60 squared divided by 70 squared. So that is 0.7346 or 0.73E. 0.73 times E. So the answer is going to be A. What is meant by the efficiency of a system? Of course, we know that efficiency is equal to power output divided by power input. Useful work output over total work input. Useful energy output over total energy input. It is always output over input. So this one is wrong. If it is input, energy wasted by the system divided that is wrong. It is useful energy. Energy output from the system divided by the energy wasted. It is always with the energy input. So the answer is going to be C. Useful energy output of a system from the system divided by the total energy input. So is output, useful over input. When an object of mass m is raised through a vertical height h, the gain of its gravitational potential energy is given by that, where g is the acceleration of free fall. The definition of which physical quantity is needed to derive this equation. Of course, mg is weight, which is force, and this one is distance, so this should be work done. So we know that work done is equal to force times distance, where the force, when you are raising an object, the force is mg, and the distance is the vertical height. So the answer is going to be D, work done. Okay. three identical springs, each with the spring constant, each with the same spring constant. So K is the same for all of them, are connected together in four different arrangements as shown. Which arrangement has the largest combination, the combined spring constant? Okay, let's check the largest. So here the spring constant is K, this is K, this is K. For springs in series, total spring constant is got from the reciprocals, and for in parallel, we just sum them up. In parallel, total spring constant increases. In a series, spring constant becomes smaller because in a series it becomes easier to stretch. In a series, it becomes easier to stretch. In parallel, it becomes harder to stretch. So it automatically means the answer is going to be B. We can verify this. So these two are in series. When I combine them, total constant for these two is going to be just half. So it will be K over 2 for these two. Then that with that, so here total constant is going to be, because they're in parallel now, K over 2 is in parallel with the K, total constant will be K over 2 plus K, which gives me, I think that is going to be, is that K? So this is going to be LCM is 2. No. If they're in parallel, extension decreases, spring constant, so you just sum them up. So this is K over 2 plus K, which would be 2, and I think this is going to be LCM is 2. I think that is 3K. That is 3K. Let me check with the extension. If this has an extension E on its own, this one is in series, the extension here is E plus E, but total extension here will be, this is E, 2E and E, total extension is going to be actually 2E plus E divided by 3, which is going to be 2E over 3. So this is 3 over 2K. Here it is K and K and K. Total extension is going to be 3K. This is total constant. K total is going to be 3K, which means total extension is just the reciprocal, which will be 1 over 3 times E. If the springs are in parallel, it becomes harder to stretch them. So their total extension is just a half. I mean, just a fraction of the extension of the extension of 1. So if there are 3, if it was alone and it extends by E, if there are 3 now, the extension becomes a third of E. If they are used together, it becomes harder to stretch. And the spring constant is just the reciprocal of the coefficient of the extension. So here, total extension is E over 2 for these two, and this is E. When you sum E over 2 plus E total is going to be E over 2 plus E, which gives us 3 over 2E. And when you get the reciprocal, total extension is, so this is total extension, then total constant is the reciprocal, which is 2 over 3 times K. 2 over 3 times K, just get the reciprocal of the coefficient. Then this one is E plus E plus E. Total extension is going to be 3E. That means a total spring constant, K total, is going to be the reciprocal, which is 1 over 3 times K. So the greatest constant is this one here. So the answer is B. The force extension graph for a wire is shown. Which rod could identify the labels X, Y, and Z? Of course, this one is the region of, this is the elastic region, and this must be the plastic region. But the straight line stops here, so this is the proportionality limit. This is the proportionality limit. Okay, let's check. X must be elastic, Y plastic. X is elastic, X is elastic, region of elastic deformation must be X, plastic deformation must be Y. So these ones are wrong. Elastic deformation is X, plastic is Y. So it means Z is the limit of proportionality. So the answer is going to be D. X and Y are 2 points on the surface of a water in a ripple tank. A source of constant frequency generates a wave which travels past X and Y, causing them to oscillate vertically. Okay, what is the phase difference between X and Y? So I just find the distance out of step. In terms of a complete cycle, if this is one complete cycle of wavelength, lambda, you notice that this distance here is a half plus a quarter, which is 3/4. So this distance is 3/4 of a wavelength. So this is going to be the distance out of step. So the phase difference is going to be 360 degrees into X over the wavelength. X is the distance between the two particles. So this is going to be 360 degrees into 3/4 of a cycle divided by wavelength. So it is just going to be 360 times 3 divided by 4, which is 270. So phi is going to be 270 degrees. So the answer is going to be D. Transverse wave on a rope has a wavelength lambda and period t. The graph shows the variation of the displacement of the particles of the rope with the distance in the direction of travel of the wave at time t equals to 0. Okay, so at time t equals to 0, that's what we have. A particle X is labeled, which graph shows the variation of the displacement of the particle X with the time t. So at time t equals to 0, the displacement of particle X is 0. But remember, particle X, the particles here, so if this was vibrating upwards, the particles here, when a trough is formed, the particles now vibrate downwards. X was going downwards at X equals to 0, at t equals to 0. So it means our graph should be at the bottom after t equals to 0. If we sketch displacement against t for particle X, it was vibrating going downwards from the displacement distance graph. So it means at time, after time t equals to 0, its displacement should be downwards. So A is going to be automatically not correct because after t equals to 0 for particle X, its displacement is upwards. Then B is also not going to be correct. Automatically, we have to look at D and C, but D is wrong because at t equals to 0, remember the displacement was 0. So the graph starts from 0. Because at t equals to 0 from this graph here, the particle is along the x-axis. So that means the displacement should be 0 at t equals to 0. So B and D are automatically wrong because the displacements at t equals to 0 are maximum. But then A and C, the answer is going to be C because when you look at the particle at t equals to 0, it was vibrating, it was tending to go, it was just passing equilibrium. So it means the vibration is going to be down. So the answer is going to be C. A source of sound waves is moving at a constant speed directed towards a stationary observer. It is towards. So it is towards. Therefore, I will say, since it is towards, I will say that F of observer is equal to V over V minus V source times frequency of the source. It is towards a stationary observer. The observer here has sound of frequency 650, which is higher than 480. What is the speed of the source? So I will simply say 650 should be equal to 340 divided by 340 minus the speed of the source, then times 480, which means 340 minus the speed of the source is going to be equal to 340 times 480 divided by 650. So I will say V of the source is going to be 340 minus 340 times 480 divided by 650. Okay, so 340 times 480 divided by 650. So I'll say 340 minus the answer, which is 88.9 or approximately 89. So this is going to be 89 meters per second. So the answer is going to be A. A student is investigating two electromagnetic waves x and y in a vacuum where wave x has wavelength 5.2 exponent minus 7. Wave y has frequency 9.4 gigahertz. Which principal regions of the electromagnetic spectrum contains wave x and y? I will start with wave x and y. Remember, Reed's mother is visiting Uncle Xavier's garden. This wavelength of 5 is in the visible spectrum. 5, because we know red is 7 times 10 to the power of minus 7 meters. And the violet is, this is red, next to infrared. Violet color is 4 times 10 to the power of minus 7 meters. So it means 5.2 times 10 to the power of minus 7 is in the visible region. And that means x is in the visible region. X is in the visible region. Without checking the rest, the answer is C. Because x is in the visible region, a wavelength of 5.2 times 10 to the power of minus 7 is in between 7 exponent minus 7 and 4 exponent minus 7. You must know these wavelengths for visible light. So the answer is C. A plane polarized light wave of intensity I naught is instead normal on a polarizing filter. The initial intensity of the transmitted wave is 0. The initial intensity of the transmitted wave is 0. Okay. A second polarizing filter is then inserted between the source and the first filter. So we bring in the second one. Its transmission axis is at 45 degrees to the transmission axis of the first one. So it means the angle between the transmission, which is going to be theta, is automatically 45 degrees. What is the intensity? What is the intensity of the transmitted wave from the filter combination? Okay. So from the filter combination, for the first one, since now we have the first one, the angle between the axis of transmission and the beam of light is 45. So for the first one, I1 is going to be equal to I naught cos squared theta. And this means I1 is going to be I naught cos of squared theta of 45 degrees. And this is going to be equal to, remember this was at 90 degrees to the first one was at, for the first one, it was incident normal. So if it emerges here as I1, it will just continue through as I1. So I2 will be the same as I1. I will not repeat this again because the angle will not be changing. So this is going to be I naught. What is cos of 45? I think is 1 over root of 2, but this is squared. This is 1 over root 2 squared. So for the first one, it is going to be I naught over 2. Then, if we say that the angle of transmission again, of course, the I1 which goes through the first filter should now enter into the second filter through the same angle 45 degrees. So it means I will again say I2 is going to be I1 cos squared of 45. So I will say I2 is going to be I naught over 2 times again 1 over root 2, but this is again squared. So this is going to be I naught divided by 4. So it means the answer is I naught over 4. So for what goes into the first one is going through an angle of 45 degrees. It is at an angle of 45 degrees. So the axis of transmission is at 45 degrees. Now, for the second one, the axis of transmission is also going to be 45 degrees relative to the first one. That's why I considered 45 degrees for I2. As simple as that. What can explain how stationary waves are formed from progressive waves? Stationary waves. So what can explain how? Of course, diffraction cannot, polarization cannot, superposition, two waves must meet at a point. So the answer is going to be C. Doppler effect cannot explain how stationary waves are formed from progressive wave. Not until they superpose. Superposition is what explains how stationary waves are formed. So the answer is automatically C. A ripple A pipe has length 2 meters. It is open at one end and closed at the other end. Okay. A stationary sound wave is set up within the pipe. There are 4 nodes and 4 antinodes. So I'll just try to connect these to form something like this. Okay. What is the wavelength of the sound wave? So this is a half, one wavelength, 1.5 plus a quarter. So we have one wavelength plus a half a wavelength plus a quarter. This is equal to 1 plus a half plus a quarter. I think that is 2 quarters. Let me see. 1 plus 0.5 plus 1 plus 0.5 plus 0.25. So this is 7 over 4. 7 over 4 of wavelength. So 7 over 4 wavelength is represented by 2.0 meters. So the wavelength is going to be 4 times 2 divided by 7. So we have 4 times 2 divided by 7, which is 1.14. 1.14 or 1.1. So the answer is going to be B. It can't be 1.2. It is 1.14 or 1.1. The teacher is explaining diffraction to a group of students. Remember, diffraction is maximum when wavelength is almost the same as the size of the gap. And this can be demonstrated using a ripple tank. Which piece of apparatus is most appropriate for the teacher to use to demonstrate diffraction? Of course, this is a ripple tank. You can't explain diffraction on a longer spring. You can't explain diffraction on a rope or a stretched string, but using a ripple tank, where you can put barriers or you can create slits. Coherent light of constant wavelength is instead normal on a double slit. Interference fringes are formed on a screen that is a fixed distance from the double slit. The screen is parallel to the double slit. Remember, if it is a double slit, the first thing to come into your mind is lambda is equal to AX divided by D, which means the graphs here are X against A. So I'll make X the subject. So X is equal to lambda times D divided by A. So you notice that X is inversely proportional to A. Which graph best shows the variation with slit separation A of the spacing X of the interference? So we are saying X is inversely proportional to A. So it means C is out and D is out. So we have to choose between B and A. So if I check that when A, if the slit separation tends to 0, if the slit separation tends to 0, it means X becomes large, it tends to infinity if we substitute in that equation. So it means the graph should not touch any of the axes. So this is wrong. This is going to be correct. You can also make A the subject, so A is inversely proportional to X. And you say that when X tends to 0, still A tends to infinity. So the graph is exponential, the graph is asymptotic to the axis, doesn't touch the axis. So the answer is A. Light of wavelength 690 nanometers passes through a diffraction grating with 300 lines per millimeter. 300 lines per millimeter. It means the number of lines is going to be 300 times 1000 to make them lines per meter. That is per meter. So the slit separation is equal to 1 over n, which will be 1 over 300,000. Okay. So what is the total number of bright spots? If we want the total number, the total value of n, we know that sine theta should be maximum and should be equal to 1, which means the theta should be equal to 90 degrees. Okay, so we know that for diffraction grating, n lambda is equal to d sine theta. So n is maximum when sine theta is equal to 1. So it means n is going to be equal to d, which is 1 over 300,000. Sine theta should be 1 divided by the wavelength, which wavelength is what is the wavelength? 690. So it is 690 times 10 to the power of minus 9. So this is the same as 1 over 300,000 times 690 times 10 to the power of minus 9. So I'll just press my calculator. 300,000 times 690 exponent minus 9. So I'll say 1 divided by the answer. So this is 4.8. So I round off. It is supposed to be 4. It can't be 4.8. I'll round off this to 4. Now note that this is only on one direction. So the maximum on one side goes to n equals to 4. Remember, at the center there is n equals to 0. The central bright maximum, that is 1, plus these 4. 1, 2, 3, and 4. Then on the other side, we also have 4. 1, 2, 3, and 4. So you have 4 plus the central bright fringe, which makes the answer to be 9. So this is equal to 9. A fine mist of oil droplets is sprayed into air. As the oil droplets leave the nozzle of the spraying device, they become electrically charged. What is not a possible value of the charge on an oil droplet? Remember, the charge on an oil droplet is going to be a whole number times E, either plus or minus, where n is 0, plus or minus 0, 1, 2, and so on and so forth, because charge is always quantized. So what is not a possible value? So this one is possible. When I divide this by, remember, E is equal to 1.6 times 10 to the power of minus 19. When I divide 4.8 by 1.6, I get a whole number, which I think is 3. So this one is possible. When I divide 8 by 1.6, let me check 8. It is a whole number, so this is possible. So this one is not going to be possible because the smallest charge is 1.6 times 10 to the power of minus 19, not 1.0. So the answer is B. In the circuit, a fixed resistor X is connected in series with a battery and a variable resistor. The power dissipated in a resistor is X is 7.2. So the power in X is 7.2. Okay, so I will say power in X is 7.2. But remember, power dissipated in a resistor is the current squared times the resistance, which is going to be resistance of X. So, and the current is 3.0. So it means the resistance of X is going to be 7.2 divided by 3.0. I think this is, what is 7.2 divided by 3 point, oh sorry, this is 3 squared, not 3.0 squared. 7.2 divided by 3.0 squared. So divide by 3 squared. What is this? 7.2 divided by 3 squared. I think that is 0.8. So this is 0.8 ohms. That is the resistance of X. So this is 0.8 ohms and it is fixed. Then the variable resistor is adjusted so that the power dissipated in X increases by 50%. Okay, remember the resistance is of course going to be constant. So the new power, we're calling it power 2, is going to be 50%, which is 100 plus 50, which is 150. 50% of 7.2. That is the new power, which is the same as 150 over 100 times 7.2. Or you can simply say 1.5 times 7.2 watts. That is the new power. And this is the same as 1.5 times 7.2. So the new power is 10.8 watts. So what is the new current? Of course, the resistance of X is remaining constant. So I will say, since power is equal to I squared times R, so I will say 10.8 is equal to I squared times the resistance, which is 0.8. So I will say that divided by 0.8. Then I find the square root square root of the answer, which is 3.67 or 3.7. So I is going to be 3.7. So the answer here is going to be automatically B. The PD across a metal wire is kept constant. The length L and the diameter D of the wire are both varied. So V is the same, L and D are varied. The type of the metal is kept the same, so it means resistivity is the same. How is the current in the wire related to L and D? Okay, so remember V is equal to I times R, which is the same as I. Remember, resistance is resistivity times original length over cross-section area. So V is equal to I rho L over A. And remember, area is pi d squared over 4. So it means V is going to be equal to I times rho times L times 4 divided by pi d squared. So the question is, how is the current in the wire related to L and D? So I make I the subject. So I is going to be pi of V, pi d squared divided by 4 rho L. So we notice that I is directly proportional to d squared. And you notice that I is inversely proportional to L because V is constant, pi is constant, 4 is constant, rho is constant because it's the same metal. So I is directly proportional to d squared. I is directly proportional to d squared, which is this part here. This one is wrong. This is wrong. This is wrong. So automatically the answer is going to be D. I is directly proportional to d squared and it is inversely proportional to L. So that is correct. A student sets up a circuit. The circuit diagram shows how the positive and negative terminals of a voltmeter are connected to the circuit. The voltmeter has an initial reading that is positive. Okay. If the initial reading is positive, then the current is entering through the voltmeter from this point here. Okay. So let's say the EMF here is 6 volts, and let's say initially the resistors here are identical. We say here it is 3 volts, and here it is 3 volts. Remember, the current is traveling in that direction. So since the voltmeter has an initial reading that is positive, it means initially I'll call this one resistance of the thermistor, and I'll call this one resistance of the LDR. LDR. I'll call this one R1. I'll call this one R2. So initially, I'll put this one this side. Initially, because current is flowing in this direction, it means the potential here is greater than the potential the other side, which means the PD across the thermistor, the PD across RT is greater than the PD across R2. So initially, R2, RT, that is for the thermistor, is greater than R2 initially. And which changes, if any, in temperature and light intensity would cause the voltmeter reading to decrease. So if you want the voltmeter reading to decrease, so since RT was initially greater than R2, so first of all, we must reduce RT. So we must reduce RT. RT should be decreased. So to decrease V, RT should first of all be decreased. Make the positive side smaller. The one which is at higher potential should be made smaller. And how do I make RT smaller? To make RT, or to make the PD across, what am I saying? I'm saying PD, not resistance. V across RT is initially greater than V across R2. So to decrease V, I must make sure the PD across RT first of all decreases. And how will I make the PD across RT to decrease? By reducing the resistance of the thermistor. So the resistance of the thermistor will decrease. How does the resistance of the thermistor decrease? This one decreases if the temperature increases because the resistance of the thermistor is inversely proportional to temperature. So the resistance of the thermistor, the temperature should increase. So I ignore no change, I ignore decrease, I ignore decrease. I don't even need to check the rest. To make the PD across the thermistor to go down, so that because it's at the high potential, I must make sure that the resistance of the thermistor decreases. And how will the resistance of the thermistor decrease? Resistance is inversely proportional to temperature. I must increase the temperature. So it means this one will be the PD across the thermistor will go down. That is when the temperature increases. And I should also make the PD across R2 to become I should also make the PD across the LDR or the PD across R2 to become bigger, so that the difference, when I subtract it from the PD across R2, the difference is again smaller. The only way I will make R2, the only way I can increase R2 is if I can decrease the PD across. If I can increase the PD across R2, it is by decreasing the PD across the LDR. To decrease the PD across the LDR, the resistance across the LDR must decrease. And the resistance is, remember, resistance is inversely proportional to the light intensity. So it means the light intensity must increase. So the light intensity should increase. So the answer is automatically A. Okay, I gave a lot of explanation there. Some resistors and a battery of EMF E and negligible internal resistance are connected in series, as shown. Which statement is correct? Okay, if I put a loop inside, so the sum of the EMFs is E, and it should be equal to the sum of the PDs across. The current through them is the same, so it should be equal to the sum of the resistors R1 plus R2 plus R3 plus R4 if they are different, which is the sum of the PDs. Okay, let's see what is given here. The EMF across each resistor equals the PD. That is not true because they're in series. The EMF is divided. The PD across each resistor equals the EMF of the battery. That is not true. The first statement and the second statement are the same. The sum of the EMFs across the resistors equals the PD across the battery. The word EMF refers to the battery, and PD refers to the resistor. So this one is also not correct. So the answer is going to be D. The sum of the PDs across the resistors equals the EMF of the battery, which is Kirchhoff's second law. Okay. Kirchhoff's first law is a consequence of the conservation of which physical quantity? We know that first law is charge, second law is energy. So the answer here is A. The diagram shows a network of resistors. Each resistor has resistance 6 ohms. Remember, if resistors are identical and they are in parallel, total resistance is just got by dividing the resistance of just one by the number of resistors. So these ones are 3 in parallel. So total resistance here is going to be 6 divided by 3, which is equal to 2 ohms. These are 1, 2, 3, 4, 5, 6 in parallel. Total resistance here is going to be 6 divided by 6, which is 1 ohm. These are 1, 2, 3. Total resistance here is 6 divided by 3, which is 2. Now we have 2 ohms in series with 1 ohm in series with 2 ohms. So total resistance is 2 plus 1 plus 2, which gives us 5 ohms. So the answer is going to be B. In the circuit shown, the battery of negligible internal resistance is connected in series with a pair of fixed resistors R1 and R2. The circuit is used to test whether the EMF of a particular cell is 1.5. The cell is connected between terminals X and Y in the parallel with R2. So if it is the PD across R2 should be the same as the EMF of the cell. So it means the PD across R2 should be 1.5 volts. Which statement about the test is correct? I'm saying if the test is to be correct, the PD across R2 should be 1.5, which will be 20 divided by total resistance, which is 80 times 6, which should be 1.5. The PD across XY is equal to 1.5. The PD across R2 should also be 1.5 volts. That's if the galvanometer is to give a balanced reading. That's if the reading of the galvanometer to be 0. Then the PD across R2 should be equal to 1.5, because the EMF of the cell to be tested, if it is correct, should be 1.5. So let's see what is given. The non-zero reading on the galvanometer, any non-zero reading on the galvanometer means that the cell has an EMF of 1.5. That will not be true. The battery does not need to have an EMF of 6.0 volts. That will not be true because the PD across R2 may not reach 1.5. The cell may be connected either way, round between X and Y. Round between X and Y, if I put the positive terminal this side and the negative terminal this side, I may never get a balance point because this positive terminal of one of the cells will be linked to the negative terminal, so I may never get a balance point. To get a balance point, the positive terminals should be linked. You see the positive end is joined to the positive, the negative end is joined to the negative. It's somehow linked to the negative, so this will not give you a balance. So the answer is going to be D. The galvanometer does not need a scale calibrated in amperes because if the PD across R2 is 1.5, then it is the same as the galvanometer gives no reading. The pointer remains in the same position, in the 0 position. It means the EMF of the cell is the same as the PD across R2. So even if we don't calibrate the galvanometer, it will still be useful. We just need it to give a 0 reading. This is what you call the null method. The null method of taking a reading, you mentioned this with your teacher. A reading is only correct when the galvanometer reads 0. So we don't need to calibrate on both sides of the galvanometer. Because when the reading, if the cell EMF is 1.5, remember the PD across R2 is 1.5, there is balance. So we don't need any deflection. So the answer is D. Two nuclides are different isotopes of the same element. Remember, isotopes have the same proton number, different neutron or nucleon number. So same proton number, same proton number. And remember, the number of protons for a neutral atom, number of protons is the same as the number of electrons for a neutral atom. Okay, which statement about the nuclide is correct? Neutral atoms of the nuclide have the same number of electrons. That is very true. The number of electrons is the same as the number of protons. And if the isotopes have the same element, then should have the same number of electrons. Nuclei of the nuclides have different number of protons. Those are not isotopes. Nuclei of nuclides have the same number of nucleons. Those are not isotopes. Nuclei of the nuclides have the same number of neutrons. Those are not isotopes. Isotopes, same number of protons, and same number of protons means same number of electrons for neutral atoms. So the answer is going to be A. The charge to mass ratio R of a particle is given by the equation R is charge over mass of a particle. The value of R is determined for an alpha particle, beta particle, and a proton, which list shows the particles in order of increasing magnitude of R. So let's check. R for alpha. Alpha has a charge of positive 2e. The mass of an alpha particle is 4u. So this is the same as 1 over 2 EU. Then R for beta. The charge of beta is negative E or positive E. The mass of beta is 1 over 1840 times U. So this gives me 1840 times E divided by U. Then a proton, R for a proton. The charge of a proton is E. The mass of a proton is U. So which one is the biggest? In order of increasing magnitude. So beta is the biggest. Alpha is going to be the smallest. So this is 1, 2, 3. So the answer is going to be B. Alpha, proton, then beta. So beta has the greatest charge to mass ratio. And lastly, which combination of up and down quarks forms a neutron? Of course, a neutron is up, up, down. A neutron is up, down, down. A proton is up, up, down. So we want a neutron, which is going to be C. I think that is the end of component 1, 2. Until next time, see you in component 1, 3. Bye bye.